to find out the truth table for the given circuit. So here we can see there is one NOT gate and here is also NOT gate. So these two are NOT gates, and here we can see there is a NAND gate, which is nothing but AND gate followed by NOT gate. So we can start giving inputs as 0 0. As we know, there are four possible combinations. So we can tabulate them as 0 0, 0 1, 1 0, and 1 1. So let's check for 0 0 what will be the final output. So at this terminal 0 is fed. So here we will get 1, and for this also after passing through this NOT gate we will get 1, and then these two outputs will act as inputs for this combination. So we can uh, check here 1 and 1 will be fed to AND gate. It will result into 1 only, but there is a NOT gate. So the final output will be 0 here. So we can write 0. Next combination is 0 1. So at terminal B we can feed 1. So let's check what is the output we are getting. So 0 and 1 here. This will be 1, this will be 0, 1, 0. For AND gate, 1, 0 will result into 0, but there is a NOT gate. So at the end, we will get 1. So here we can write 1. Next combination, 1, 0. So let's try some other color. 1. Okay, we can continue with the same color. So here we are feeding 1, here we are feeding 0. So this 1 will be 0 here, this 0 will be 1 here. So here we can write 0 and 1. So for AND gate, these two inputs will result into 0 only, but there is NOT gate. So final result will be 1. And the last combination, which will be 1 1. So 1 will be 0 here, 1 will be 0 here. So here these two inputs for this combination, these two inputs are 0 and 0. So for AND gate, 0 and 0 will result into 0, but there is a NOT gate, so it will be 1. So finally, last combination will give us 1. So this is the truth table for the circuit drawn here. Let's try one more example. Here we have a circuit which is a combination of NAND gate, NOT gate, and AND gate. So how the truth table can be written for this circuit? We can start giving inputs in the same manner, and we can check what will be the output. So for the first combination 0 0, here we can put 0, here also 0. So look what is happening here. This 0 will be acting as input here also, and there is one channel here. So this 0 will be passing through this NOT gate. So it will be 1, and then this 1 will be one of the inputs here. And now this 0 will be here, and there is nothing like NOT gate or some other gates here, a simple connection here. So there will be 0 as input. Now 0 and 0 after passing through AND gate will result into 0, but there is a NOT gate following the AND gate. So the final result here will be 1. And in this case, the final result is 1 as well. So 1 and 1, the final result will be 1 because this is simple AND gate. So we have 0 0 1. We can move to next combination, which is 0 1. Let's check. what is happening. So 0 and here we are feeding 1. So this will be the same 0 and here we are getting 1 as it was in the previous case. And here we are getting 1, here we are getting 1. So 0, 1 after passing through NAND gate will result into 1, 1, 1. After passing through AND gate, it will result into 1. But there is a NOT gate here. So we can write 1 1 resulting 1, and after passing through NOT gate it will be 0. So here we are getting 1 and 0, and the final result will be 0. So the second combination 0 1 will be 0 only. Now moving to the next combination, which we can write 1 0. So let's check what will be the output. Here we are feeding 1, here 0. So this will be 1 only, and here we are getting 0. So here we have 0 and 0, and the same 0 will be acting as input here. Now we have 1 0. After passing through NAND gate, it will be 1, and 0 0. After passing through NAND gate, it will be 1. So 1 1, and the final result will be 1 here. We can write 1. And now moving to the last combination, which is 1 and 1. So here 1. So 1, here we are feeding as input, and this one is also being fed here. So after passing through this NOT gate, it will be 0 as it was in the previous case. So let's check about this. 1 will be here only, and the same one will be here. So 1 and 1 will result into 1, but the NOT gate following the AND gate will turn it into 0. And then we are feeding 0 here. The same result will be input at this point. And now here 0 1 will be 0 for AND gate, but there is NOT gate, so at the end it will be 1, here 1, and the final output will be 0. So 1 1 will be 0. Let's try one more example. So here we have a circuit which consists of AND gate, NAND gate, and this is OR gate. So how can we check what will be the output for the given input? Here we have input which is varying with time. Now we can check here for the first interval, let's say from T0 to T1. For the first interval, we have inputs as, for terminal A, we have input as 0. For terminal B, it is 0. And for terminal C, it is, actually it is not 5. This is high voltage, which we regard as 1. In classical bit system, we have 1 and 0, where 0 represents either off position or low voltage, and 1 represents either on position or high voltage. So we can say that this 0 volt is representing by is being represented by this bit 0, and 5, which is high voltage, we can represent by digit 1. So now we can continue to analyze the circuit. So we have 0 0 and 1. Let's check what is going to happen. Here we have 0, and here we have 0, here we have 0, here we have 1. So we have 0 0 and get 0. This is NAND gate. 0 1 will be here 1 and 0 1. This is OR gate. Means either of these two inputs, if either of these two inputs are 1, the output will be 1. So 0 or 1 will result into 1 here. So for the first time slab here, the output Y will be 1. That is high. So we can write it 0, 5. So the output will be here. Uh, I should try some different color for the final output. Okay, which we can write at the end. So this one. Let's continue. Let's continue for the second time interval. So here we have in second time interval A is means from T1 to T2 A is 1, B is 0 and C is 1. So 1 0 which will result into 0 here. Here we are feeding 0. So this 0 1 which will be 1 here. So we have 1 here. And now final result will be 1. So again for second interval again it is 1. Let's check for the third interval. So for the third interval we have inputs. Third interval is T2 between T2 and T3. So A is 0, B is 1 and C is 0. So let's check 0, 1 which will be 0 here and this one will be carried here and this 0 is here 0, 1. Final output from NAND gate will be 1. So 0, 1, Y will be 1. Again in third interval it is 1. Now checking for fourth interval that is 2, 3, 4, 3, T3 to T4. So for T3 to T4, we can write inputs as 1, 1, 0. T3 to T4. So there will be 1, 1, there will be 1, 1, 0. It is 1, 0. Then final output will be 1 here, 1, 1, and then 1. Again, we have 1. And for the next interval, T4, T5. For this interval, T4, T5, A is 0, B is 0, and C is 1. So here will be 0, 0, 0, and then here will be 0, 0, 1, there will be 1, and here will be 1. So final output will be 1. Okay, let's move to next interval, T5 to T6. We can write inputs as 1 at terminal A, 0 at terminal B, and 1 at terminal C. So here will be 1, 0. So here will be 0, 0, and then 0, 1. Final output will be 1 here, 1, and then we have 1 here. So again, in this interval, we are getting 1. Let's check for the last one. So for the last one, beyond T6, it is 0 and at B also 0 and here 1. So 0, 0 will be 0 here, 0, 1. This will be 1 here, 0, 1. This will be 1 here. So at the end, we have the final output as 1. So what is happening actually here? For the whole time, starting from say T0 and up to T6 and beyond that, the output is always 1. So we can write it single line this way. If we are indicating 0 here, this will be 5 and we can separate into the intervals T1, T2, so on up to T6. So this is the final result. So we can continue these things. I have solved these things assuming that we know the basic concepts of AND gate, means truth table, how it gives results, and the same for OR gate and NOT gate. So in case you have any doubt, you can ask in the comment. I'll make a separate video for those basic things too.